All right, this is 2.3 linear equations. We're going to talk about slope. We're going to talk about x-intercepts, y-intercepts, how to graph a line from a slope and a point, how to graph a line from 2 points, how to write an equation of a line if you have the slope and a point, or if you have 2 points, and then the relationship between the slope of parallel lines and the relationship of the slope between two perpendicular lines. So to begin with, we're going to talk about the slope of a line. The slope of the line is just referred to as the letter m, okay? The most common way to write a linear equation is y equals mx plus b, where y and x are obviously the two variables we're familiar with, and then the m is the slope and the b is the y-intercept, okay? So when you see the letter m, when we're talking about linear equations, we're talking about the slope. The slope of a line is the numerical measure of the steepness of a line, the ratio of the rise. So the rise of slope is its y value. And then the run of slope is its x value. So we're just talking about, and we kind of treat it like stairs. Over 2, up 1, over 2, up 1, over 2, up 1, perhaps, for example. So the slope m of a line containing any 2 points, P1, this is point 1, and P2, point 2, is the slope is the rise, or the y value, the difference in y values, divided by the run, or the difference in x values. So we look at slope, unless it's a whole number, even if it's a whole number, like the number 2, you can write the number as 2 over 1. So unless it's a whole number, we look at it as a fraction. The top number of your fraction is how many spaces you're going to move up, right? So this is plus 1, it looks like. And then your run is how many places you move left or right. So this is a positive slope, so maybe we're running 2. So that slope would just be 1/2. Because I go up 1, left 2, up 1, left 2. I rise 1, run 2, I rise 1, run 2. Alternately, and we'll talk about this later, the slope -1/2 would mean I start from here, I go down 1, left 2, down 1, left 2, or up 1, right 2. Okay, so that's a negative slope. And that's a positive slope. So to find the slope of the line containing the points 2, 8, and 6, -3, and if we just think about where 2, 8, and 6, -3 are, 2 up 8, 6 down 3, that's going to be a positive slope, or a negative slope, right? It's going from left to right, it's going down. So that's a negative slope. Like this one. Whereas if from left to right it's going up, it's a positive slope. Okay, so between this point and this point, we have a negative slope, so our m should ultimately be a negative number, and I should be able to move that far over under. Ooh, 1 second. Okay, I'm going to share my screen. I'm going to show you Desmos. So here's a more accurate, this is not my own drawing, of where we're at. So we're at 2, 8 to 6, -3. If I count, just count the rise. The rise is a negative number, right? We'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I went down 11 and I went over 1, 2, 3, 4. Yeah. From 8 to -3. Yeah, it's 11. And then from 2 to 6 is 4. Okay. So we've got -11/4 is our guess for the slope of this, but let's use the equation as well. So our equation is m equals y2 minus y1 over x2 minus x1. Our points are 2, 8. So that means x1 is 2 y1 is 8. Other point is 6, -3. So that point x2 is 6. y2 is -3. So we have -3 minus 8. And then we have 6 minus 2. -3 minus 8, 6 minus 2. -3 minus 8 is going to be a -11, and then 6 minus 2 is 4. So -11/4 is our slope. Down 11, right 4. Or from here, I could say I'm going up 11, but then I'm going negative on the x, 4. So either way, it'll get there. So the slope is -11/4. What would the graph of the line that contains the point 2, 1 and has a slope of 3/2 look like? So from good. So I'm going to find the point 2, 1, 2 on the x, 1 on the y. 2 on the x, 1 on the y. So I'm doing two different graphs. From the point 2, 1, this first slope is 3/2. So my slope is 3/2. That means I need to go up 3, 1, 2, 3, over 2, up 3, positive 2, or you could do a double negative, 1, 2, 3, -3, -2. Okay, and that's your line. Not bad for me. Usually do much worse than that in making something straight. So that's a positive slope, and if you think about it, when I'm traveling from left to right and I start traveling up along that line, that's a positive slope. Now, -5/2 means I need to go down 5. 1, 2, 3, 4, 5, left 2, right 2, sorry. So that was a -5, positive 2, or I can go up 5. 1, 2, 3, 4, 5, -2. Because if we multiply them, it's either +5, or sorry, put them as the slope. +5, -2 is the same as a -5 over +2. Either way, it's negative. And the line looks like that, and it's a negative line, right? That's a negative slope. Whereas this is a positive slope. Vertical lines are of the form x equals a, where a is the x-intercept. So graph the equation x equals 2. So at x equals 2, it's going to cross the x-intercept. It's also going to cross the x-intercept, or it's also going to be x equals 2 no matter what the y is. Okay? So it's just this line. It should be straighter than what I drew. But it's this line forever where x is 2 when y is 0, x is 2 when y is 3, x is 2 when y is -3. No matter what y is, x is always 2, so that is the equation x equals 2. Now when we think of the slope, okay, remember it's y 2 minus y1 divided by x2 minus x1, right? So if I just pick two random points, this will be my point 1, and this will be my point 2, okay? So that means my x1 is 2, my y1 is 0, my x2 is 2, my y2 is 3. Slope is 3 minus 0 over 2 minus 2. Okay? 3 minus 0 is 3, but 2 minus 2 is 0. Any number divided by 0 is called undefined, okay? So our slope is always undefined, no matter what point you use. If you use a point way down here and a point way up there, it's still going to be 2 minus 2, which is still going to be 0, which is still going to be undefined. So a straight up and down is undefined. Ooh, another point is, if it has an x in the equation, it crosses the x-axis. So because of this x, you are going to have an x-intercept. X equals 2 will have x-intercept, will cross the x-axis. But there's no y. Will not, because there is no y, it will not have a y-intercept. We're going to talk then about horizontal lines. You only have a y. Okay? Y equals. So you will cross the y-intercept. Will not cross the x-intercept. Okay? It will have, will cross the y-axis. Will have a y-intercept. We'll cross the y-axis. We'll have x-intercept. We'll cross the x-axis. We'll cross y-axis. We'll have a y-intercept. It's the same thing. But here the slope is 0. So here find an equation of a horizontal line containing the point 2, 3. So here's the point 2, 3. It's a horizontal line. So it's going to involve the point 2, 3, but it's also going to involve the point 0, 3. And over here, it'll involve the point negative 503, right? No matter how far along this line I go, it will remain 3 as its y value. So in that case, x1 will be this one. x1 is 0, y1 is 3, x2, I'll make this one, is 2, y2 is 3. Slope is y2 minus y1 over x2 minus x1. So that means I have 3 minus 3 over 2 minus 0. 3 minus 3 is 0 over 2. 0 divided by any number is going to be 0. So that's going to be a 0 slope. Horizontal lines have a slope of 0. Okay? It has an x-intercept, it has a y-intercept. It will never have an x-intercept. Just try to find a way that you can memorize the separation between horizontal lines and vertical lines, and which one has an x-intercept, which one has a slope of 0 and which one has a slope that is undefined. The equation of a non-vertical line with a slope m that contains the point x1, y1 is y minus y1 equals the slope times x minus x1, okay? So find the form of an equation of the line with slope 3, that means that m is 3, containing the point 1, negative 4. So P1 is 1, negative 4. So that means my x1 is 1, my y1 is negative 4, right? So that negative x1 is going to be a negative 1, and that negative y1 is going to be a negative negative 4. Here's my m, here's my y1, here's my x1. Y minus y1 is the equation, is equal to m times x minus x1. Now I'm going to replace those numbers. I'm going to put 3 in for m, 1 in for x1, negative 4 in for y1. Y and x remain because those are what we have for solving the equation, minus 1. Okay? So y minus a negative 4 becomes y plus 4 equals 3 times x minus 1. I'm going to distribute that 3. Y plus 4 is equal to 3x minus 3. And like I said, now you have a y and an x. That's a normal linear equation, 1y and 1x. I'm going to subtract the 4 so I can solve for y. Y equals 3x minus 7. So the point slope form of the line is y minus negative 4 equals 3 times x minus 1. And then the slope intercept form is y equals 3x minus 7. Y equals mx plus b. It's my favorite one, so I skip to it. I turn them all into y equals mx plus b. Okay, so if you have an equation 2x plus 3y equals 6, what you should know is that if you can get it into y equals mx plus b like this one, y equals mx plus b, m is your slope, b is the y value of your y-intercept. So you see y equals 3x minus 7, but now that you know that, you might also see that as a line. The line's going to begin at negative 7 on the y, and then the slope is going to be 3. So that means up 3, 1, 2, 3 over 1. 1, 2, 3 over 1. So once you see the slope intercept form of the line, you can start at B on the y-axis and then move up or down M and create your line. Slope is the letter M. Y-intercept is the letter B. Make sure to recognize whether it's negative or positive, okay? So if you have the equation 2x plus 3y equals 6, they're asking us to find the slope M and the y-intercept B, and then to graph it. You can't just say that the number next to x is your slope and that the 6 is your y-intercept, because it's not set equal to y. So the first thing you want to do when you have an equation in this form, this is called standard form. When you have it in standard form, change it to the slope-intercept form of the line. So I'm going to subtract 2y here. Sorry, subtract 2x. And I'm going to get 3y equals negative 2x plus 6. Good. It's still not set equal to y. I still need to divide by 3. 3y divided by 3 just gives me y equals negative 2/3 x plus 6 divided by 3 is 2. Okay, now I know my b is a positive 2 and my m is a negative 2/3. That means I start at 2. I go down 2. 1, 2, left, or sorry, right 3. 1, 2, 3. Down 2, right 3. That is the slope of my line through the y-intercept positive 2. And we can graph that in Desmos. So here's 2x plus 3y equals 6. And then here's how we changed it to y equals negative 2/3 x plus 2. Same equation. It will cross the y-intercept at positive 2 because that m is equal to 2. And its x-intercept is 3, 0. So it's just to verify that we know what we are doing. So we also have something called, so now we know how to find an equation of a line when we have the slope and one point, right? It's called the point slope form. Y minus y1 is equal to m times x minus x1. So if I have one point and I have the slope, I can find the line, okay? We found the slope of between 2 points as the very first exercise today. It was listing x1, y1, x2, and y2, and then saying that m is equal to y2 minus y1 divided by x2 minus x1, right? That is going to give you the slope or your rise up or down over your run left or right, okay? So let's just decide x1, x2, sorry, x1, y1, x2, y2. It was bound to happen, right? X1 is 3, y1 is 2, x2 is negative 3, y2 is 4. Now we're just going to replace those into the equation for a slope and solve it. So we got 4 minus 2 divided by negative 3 minus 3. Good. 4 minus 2 is just 2. Negative 3 divided by negative 3 is a negative 6. 2 divided by negative 6 is a negative 1/3 if you want to simplify it. Okay, so we've got a slope of negative 1/3. That means I'm going to go from this point, I'm going to go down 1, right 3. Or I can go up 1, negative or left 3. That's going to be our slope. Down 1, left 3, which is also down 2, right 6, or up 2, left 6, okay? We just simplified it from 2, negative 6 to negative 1, 3. Now we have an m of negative 1/3. We have a y1, just choose whichever one looks easier, I guess the 2. And an x1, which is the 3, okay? So now, oh, sorry, you couldn't see that. So we have our slope of negative 1/3. We have our y1 and our x1. You don't have to use this one. Use whichever one looks easier. This one looks easier because there's no negatives. So my y1 is 2 and my x1 is 3. So I'm going to rewrite that as y minus y1 is equal to m times x minus x1. Y minus, instead of y1, I'm going to put in a 2. And it was a positive 2. Equals, instead of the slope, I'm going to put in negative 1/3 because that's what we got by using the equation for slope. Leave x and y just in there, minus, and then x1 is 3. Now we're going to simplify. Y minus 2 is equal to negative 1/3 x plus 1/3 times 3, all right? So that's a negative times a negative becomes a positive. The 1/3 times the 3 becomes a 1/3 times 3. You can also call it 3/1 if you want, okay? Or y minus 2 is equal to negative 1/3 x minus 1/3 times negative 3. Right? So that's what I kind of like shortened into. Negative times negative becomes a positive. 1/3 times 3. So I hope that that's okay. Y minus 2 is equal to negative 1/3 x, 1/3 times 3 is 1, right? We're taking that 3, multiplying it by 1, dividing it by 3. Or 3 times 1 is 3, 3 times 1 is 3, 3 divided by 3 is 1. So it's plus 1. Good. Add 2, add 2. Y equals negative 1/3 x plus 3. That is the equation of the line containing the points 3, 2, and negative 3, 4. So when I graph, when I graph the point negative 3, 4, that means negative 3 on the x, 4 on the y, and 3, 2, That should also be the line y equals negative 1/3 x plus 3. So if I go up to 3 on my y-axis, 1, 2, 3, I should go through the point 0, 3. And then I should be able to go down 1, right 3, down 1, right 3, or up 1, left 3, and find points on that line, which those are both points on the line with 0, 3. So I think this is the correct equation of that line. You can also check it in Desmos this way. So here is the equation. Y equals negative 1/3 x plus 3. Don't put the x down here. Make sure it's either up here or to the side. And then graph your point negative 3, 4. Make sure it's on that same line. And then graph the point 3, 2. Make sure it's also on that line. So that's another way to check. So when an equation of a line is written in general form, it's written as ax plus by equals c. It is my least favorite form, but there might be 1 or 2 questions on it. So this is general form. So write the equation x minus 3 equals 2 times the quantity y plus 3 in general form and graph by finding the intercepts. So x minus 3 equals 2 times y plus 3. I'm going to distribute the 2 first. X minus 3, I'll leave that side alone, equals 2y plus 6, right? So what I want are my x and my y to the left, and then my constant on the right of the equal sign. So I'm going to add 3, and what I get is x equals 2y plus 9. And then I need to move that y over. So it's going to be x minus 2y is equal to 9. That's general form. It's kind of alphabetical, x, y, constant. And then form the graph by finding the intercepts. This is just good finding x-intercept and y-intercept practice. So remember, to find your x-intercept, y is 0. So we have x minus 2y equals 9. X minus 2 times 0 equals 9, right? X minus 0 equals 9. X is 9 when y is 0. So my x-intercept is 9, 0. My y-intercept I find when I put x equal to 0. X minus 2y equals 9. 0 minus 2y equals 9. Negative 2y equals 9. Divide by negative 2. Divide by negative 2. Y equals negative 9 halves. Not as lovely when x is 0. So that will be 0, negative 9 halves. So 9, 0 will be up here as my x-intercept will be 9 zeros up here. And then negative 9 halves would be negative 4.5. Maybe right there. So that's how I would graph that. You're also welcome to put it into Desmos to find the x-intercept and the y-intercept. Let's do that. Let's see what happens. All right, so here's the original x minus 3 equals 2 times the quantity y plus 3. If I erase that, I still have the same line as x equals 2y plus 9. And then if I try to find my intercept, it's at 0, negative 4.5. And if I divide negative 9 by a 2, I get negative 4.5. And then my x-intercept should be 9, so that one works as well. So that one was okay. Now we're just going to talk about parallel lines and perpendicular lines, okay? I know this is a lot for one day, but You got this. Lines in the same plane that never intersect and have the same slope but different y-intercepts are considered parallel. So just think of a pair of train tracks. They will never touch, right? This line is parallel to this line. They are never going to cross each other. Are the lines parallel? They should have the same slope. Okay? The same slope, but different y-intercepts, because the same slope and the same y-intercept would just be the same line. So L1 just means first line. L2 means my second line. Find their slope or put them into Desmos. And if they look like train tracks, if you can count the slope and they both have the exact same slope, you're also good. But what I would do is put it into y equals mx plus b format, slope intercept form, because I will be able to see what my slope is algebraically. Okay, so I'm just going to move my x over and divide by 2. I'm going to move my x over and divide by 4. See if I have the same slope but different y-intercepts. Okay, x plus 2y is 6. Move my x. 2y equals negative x plus 6. Divide by 2. Y is, you can just call it negative x over 2. Or you could say y equals negative 1/2 x. Those mean the same thing. It's either 1 times x divided by 2 or x times 1 divided by 2, right? Saying the same thing. So that's L1. L2 is 2x plus 4y is 0. I'm going to move my 2x. I have 4y equals negative 2x. Divide by 4. Divide by 4. Y equals negative 1/2 x. So that's the same slope. Right? And different y-intercepts, because here my y-intercept is 3. What's my y-intercept here? It's 0. It's going to go through the origin. Okay, so let's graph it in Desmos and see what we get. So my green one is my negative x over 2 plus 3, and then my purple one is negative x over 2, and it certainly looks like train tracks to me. On paper, they have the same slope and different y-intercepts, so I'm going to say they are parallel. Perpendicular lines. Oh, sorry. Example. Find an equation for the line that contains the point 1, 0 and is parallel to the line x plus 2y equals 6. So what do I need to do? I need to find the equation for a line that has a slope that is the same number as the slope of this guy and has the point 1, 0. So I know that my x1 is 1, my y1 is 0, and my m is whatever this guy's m is. And then I'm going to use the only thing I can use when I only have one point and the slope, y minus y1 equals m times x minus x1, right? Okay, so let's just find m by simplifying this into y equals mx plus b. Okay, and that's how we'll find our m, and we'll make that m this m because they are parallel. Parallel means they have the same m or the same slope. Good? All right, let's move the x. So we just have 2y equals negative x plus 6, divide by 2, divide by 2, divide by 2. So I have y equals negative x over 2 plus 3. My slope is negative x over 2 or negative 1 over 2, right? Okay. Y minus, y1 is 0, is equal to negative 1/2 times x minus x1, which was 1. Good. Y minus 0 is just y. Negative 1/2 x minus 1. I'm going to distribute the negative 1/2 is going to be multiplied by the x. And then negative times a negative is a positive. 1/2 times a 1 is just a positive 1/2. Good. So an equation of a line that contains the point 1, 0 and is parallel to the line x equals 2y, x plus 2y equals 6. I'm going to put them both into Desmos. And actually, that was the same, that first equation, y equals negative x over 2 plus 3, is the same equation we had from our original example. And then here is the other line we found, y equals negative 1/2 x plus 1/2. And then we also, so it's parallel to the green line, and we want to make sure it goes to the point 1, 0. And it does. So it's parallel to the green line, and it goes to the point 1, 0, so it meets the demands of the question. Good? So that's how you would find a parallel line to this equation going through this point. Perpendicular lines intersect at a right angle, and the slopes are opposite reciprocals. So if a line has a slope negative 1, 2, then any line having slope 2, 1 would be perpendicular to it. So negative means we change from a negative to a positive, or a positive to a negative. And reciprocal means we flip. The top of the fraction goes to the bottom of the fraction goes to the top, okay? So negative 1/2, the opposite of negative becomes a positive, and the reciprocal of 1/2 becomes 2 over 1. So a negative 1/2, the opposite reciprocal is positive 2 over 1. Positive 2 over 1 is just positive 2. Example 12 is just like example 10. Remember in example 10, they gave us a line. They said parallel to this line containing the point 1, 0. So we used y minus y1 equals m times x minus x1. Okay. We know y1 and x1 because they gave us 1 point. We need to find, not here we needed the same slope. Here we need to find the negative reciprocal, or the opposite reciprocal of this slope, okay? Step 1, solve the slope. So we know, actually, step 1 is that I already know that y1 is equal to negative 2, right? And I know that x1 is equal to positive 1. So that's already y minus negative 2 is equal to m times x minus 1, right? I know that based on the point they gave us. Now I need to find m. M is going to be the opposite, change the sign, reciprocal, flip the fraction, okay? To find the perpendicular line to x plus 2y equals 2. Good. Just solve it for y equals mx plus b because we're trying to find m. Subtract x, 2y equals negative x plus 2, divide by 2, divide by 2, divide by 2, right? Y equals negative 1/2 x plus 1. It's also negative x over 2, but because we're taking it as a number, I want it separate from my x. So instead of negative x over 2, it's negative 1 over 2 times x, okay? So we don't want the same slope. We don't want a parallel slope. We want a perpendicular slope. So we take the opposite of a negative 1/2 is 1/2, okay? But the reciprocal is 2 over 1. So first I changed the sign, then I changed the location of each number above or below the fraction. So the opposite slope of negative 1/2 is positive 2. And let's look at that really quick on Desmos. So here is a negative 1/2 slope, right? Negative 1/2 x, which is also negative x over 2, right? Same line. And then we say positive 2 is the perpendicular line to that. And you can see that it makes a 90 degree. It wouldn't be negative 2, and it wouldn't be negative, and it wouldn't be positive 1/2 x. It would only be the negative reciprocal. I'm trying to make a 90 degree angle, okay? So now we know y1 is negative 2, x1 is 1, and that m is 2. Good. So we have y minus negative 2 is equal to 2 times x minus 1. Y minus a negative 2 is y plus 2. I'll distribute that 2. Y plus 2 is equal to 2x minus 2. Subtract 2. Subtract 2. Y equals 2x minus 4. Good? Y equals 2x minus 4 contains the point 1, negative 2, and is perpendicular to the line x plus 2y equals 2. If we put both of those into Desmos, we see that they are at a 90 degree angle. Oh, I always forget this part. And you need to make sure, verify with a graphing utility, that it goes through the point as well. And it does go through the point. All right, and that is the end of 2.3. Thank you so much. I know that was a long one. Yeah, I hope that your homework goes well.